Okay, this problem is a easy problem. So let us say this says there is an elevator. So we have an elevator here. This attaches a pulley, and this pulley has two masses, masses m1 and masses m2. So let us say this mass is m1, another mass is m2. Now this gives, so question says this elevator is going up with acceleration w naught. So the acceleration of this elevator is w naught. First part of the question says find out the acceleration of m1 with respect to elevator. So this we have to find with respect to elevator. And the second part says what is the force that is exerted by the pulley on this shaft? Basically force exerted by the pulley on the ceiling of the car. So this is the ceiling of the car, that is the ceiling of the elevator. So what is the force exerted by this pulley on this ceiling? So force on ceiling. Force on ceiling. So the second part you have to find out the force on ceiling. So this is a basically easy problem. This is something related to the concept of the pseudo force. Are you getting? So concept of the pseudo force. Now if you think this elevator, the frame of elevator is a non-inertial frame, because this elevator is going up with acceleration w naught. So this is a non-inertial frame. If I want to write down the Newton's second law, I have to apply a pseudo force. So let us apply the pseudo force on m1. So let us draw the free body diagram for m1 and m2. So for m1g, that is acting downward, another force that is acting, let us say tension, and this elevator has w net acceleration up, so pseudo force will come down. So this pseudo force will be m1 w naught, and this, let us say this elevator is going down with acceleration a1 or simply a with respect to this elevator. So the acceleration, this acceleration a is with respect to elevator. Are you getting? So this is the acceleration with respect to elevator. Now let us consider mass m2. You can draw the free body diagram yourself. So let us take some time so that you can draw yourself the free body diagram for this case m2. So if you have drawn this free body diagram from m2, so let me see whether you have done or not. So for m2, this m2z will act downward direction, and in this case again tension will act in the upward direction. And this is, so this m1 is going down, so this has to go up because constraint condition says it has to go up. So let us say this goes with acceleration a, this is going up. Now again pseudo force on this will be acting in the downward direction. So m2 w naught is the pseudo force. So in this case m1 w naught is the pseudo force. In this case m2 w naught is the pseudo force. Now let us write equation for this object. So this is going down, so I can write m1g plus m1 w naught, this is the downward force, minus t, that is upward force. This is equals to mass into acceleration. So acceleration is a. If I write equation for object 2, this is going up, so t minus m2z minus m2 omega naught, this is equals to mass into acceleration. Now if I add these two equations, basically t goes out, this t and this t goes out, so we will have m1 minus m2z. So m1 minus m2z, we will have plus m1 minus m2 w naught, m1 minus m2 w naught, and this side you will have m1 plus m2 into z, m1 plus m2 into a. Now if you take m1 minus m2 common, you will have, let us say, m1 minus m2 common, so you will have z plus w naught. This is equals to m1 plus m2 into a. So I can solve for a. So acceleration is m1 minus m2 divided by m1 plus m2 into z plus w naught. So this is the acceleration of the pulley with respect to the elevator. Question also says find out the acceleration of m1 with respect to ground. So if I want to find acceleration with respect to ground, so you see, for mass m1, this is going down with acceleration a, but this is attached to the elevator that is going itself by w naught. So resultant acceleration of m1 in the downward direction will be a minus omega naught. So this is the resultant acceleration of m1 with respect to ground, because the elevator is going itself with w naught upward direction, a is downward direction. So resultant of a is a minus w naught, and this is in downward direction. So you can plug the value of a and omega naught, w naught, you can find out the resultant acceleration with respect to ground. So a is this m1 minus m2 divided by m1 plus m2 and z plus omega naught minus w naught. So this is the resultant acceleration of m1. So you will have m1 minus m2 z plus omega naught minus m1 plus m2 omega naught divided by m1 plus m2. So what this comes out to be? So you see, so let us say g is as it is, m1 minus m2 z, and let us say for omega naught, m1 minus m2 omega naught minus, so this becomes, so let me take omega naught common. So if I take omega naught common, this is m1 minus m1, so that goes out, minus m2 and minus m2, so this is minus 2m2 divided by m1 plus m2. So I can write resultant acceleration will be, are you able to see or not? I think you are able to see this one. So now you will have m1 minus m2 z minus 2m2 omega naught divided by m1 plus m2. So this is the resultant acceleration with respect to ground. So this is with respect to ground. Are you getting? Now we'll discuss the next part, that is the force on ceiling. So part B. So if you see, what is the force that is acting on ceiling? This side you have tension T, this side you have tension T. So this means on this side, let us say T1, this pulley is massless, so total force should be 0. So T1 minus 2T, mass of the pulley is 0 times acceleration. So T1 minus 2T, because this is T1. This side we have T, this side we have T. So T1 minus 2T is equals to 0. So T1 is equals to 2T. So this is the force on ceiling is 2T. Now I can find the value of T using equation 1. So you see the equation 1 you have written in your copy. You can check yourself. So this is the equation 1, T minus m1g minus m1w is equals to m1a. So let us put this value. So equation 1 we have T minus m1g minus m1 omega naught is equals to m1 times acceleration. Acceleration we know, we have solved. You can okay, I think what is my equation number 1? So let us say this is okay. So this is the equation once again. I am sorry. So let us say this equation. You see this equation we have T minus m2z minus m2, this is equals to m2a. So either use this equation or this. Let us use equation number 2. So T minus m2z minus m2 omega naught, T T minus M2Z minus M2 omega naught is equals to M2A. If I plug the value of, so let us plug the value of A. So if I plug the value of A, I will have M2 Z plus omega naught, are you getting, plus M2, and A is what? We have already solved, you can see on your copy. So G plus omega naught M1 minus M2 divided by M1 plus M2. So this is the acceleration. So I can solve for T. So let us say M2 G plus omega naught common. So if you take this common, so you will have M1 M2, so you will have minus, so you will have simply 2M1 divided by M1 plus M2. So resultant tension will be 2M1 M2 divided by M1 plus M2 into Z plus omega naught. Because T at the ceiling, force on ceiling is T1 is equals to 2T. So I can write force on ceiling. This is equals to, I have to multiply this by 2. So 4M1 M2 divided by M1 plus M2 G plus omega naught. So this is the resultant force that is acting on the ceiling. If you want, you can express these all result in vector terms, but for our purpose we are only interested in magnitude wise, and sign we already know. So you see acceleration, in case of acceleration we have taken acceleration in the downward direction for M1. This is the force acting on the ceiling. So let us copy this one first, and then we can go for the next problem. This is a pretty easy problem. This is simply how to apply the pseudo force. So this question asks only how you can apply the pseudo force. You have to apply the pseudo force, and then you have to solve the equation. And the pseudo force is applied only if you assume that the acceleration is with respect to some non-inertial frame. So I have taken acceleration A with respect to non-inertial frame, that is elevator. So elevator is basically non-inertial frame. So acceleration A that I have assumed in the first part, that is basically from non-inertial frame, from with respect to the elevator. If somebody take the acceleration of mass m1 with respect to ground, in that case you don't have to apply the pseudo force. Pseudo force is a good idea. If you want to solve the problem easily, if you want to make the problem simple, you apply the pseudo force. You take a non-inertial frame, apply the pseudo force. You can solve this question again using the inertial frame, that you can assume the acceleration with respect to ground. So you can also solve the same problem using the ground. In that case, what you will have, let us say, you will say mass m1 is coming down with acceleration A with respect to ground. So m1 is coming with respect to ground in downward direction, and elevator itself is going up with respect to ground. So what is the total acceleration of this? You can solve this question using that concept also, inertial frame, but it's easy to solve using the pseudo force idea, because this makes the problem simple. So this result you have to remember. So this is the force on ceiling. If W naught is 0, you have to simply 4m1 m2 divided by m1 plus m2 into 0. This is a this result you can always remember, that is W naught is 0. So you have simply two masses attached on a pulley, and the system is in the rest, that is not moving, elevator is not moving. And in that case the tension on the ceiling will be 4m1 by 4m1 m2 divided by m1 plus m2 to z, because omega naught is 0 in that case. So this result you can always remember. And this acceleration, this also you should to remember, this result, that is the m1 minus m2 divided by m1 plus m2 into z. If omega naught is 0, so this result simply becomes m1 minus m2 divided by m1 plus m2 into z. So this result also you have to remember, that the acceleration of a mass m on a pulley is given by m1 minus m2 divided by m1 plus m2 to z. These two results you have to remember. What is the acceleration of a mass when these two masses are attached on a pulley? What is the tension or what is the force on the ceiling by this pulley system? That is 4m1 m2 divided by m1 plus m2 into z. Are you getting? Let us go for the next problem.